In October 2025, humanity lost control of the sky. A massive, mysterious interstellar object, traveling at 68 kilometers per second, vanished directly behind our sun, blinding every telescope on Earth. But before it went dark, it did something impossible. It changed colors, fired an anomalous thruster-like jet toward the sun, and defied every law of physics we know. Was this just an ancient cosmic snowball, or have we just witnessed humanity's first encounter with an organized alien machine? You are not ready for what our space probes just discovered. For months, the global astronomical community watched with intense anticipation as 3I/Atlas, the third confirmed interstellar interloper, hurtled through our solar system. But in October 2025, just as this alien traveler drew close enough for detailed study, it vanished. It was not swallowed by a black hole or diverted by an unseen force. Instead, it slipped directly behind the brilliant disk of our sun, blinding Earth's premier ground-based telescopes at the worst possible moment. Before the solar blackout, the object had already defied expectations, changing color twice and exhibiting an anomalous sunward jet. Was a fragile, ancient comet undergoing a violent thermal breakdown, or did its trajectory point to something far more organized? As it braved the searing heat of Perihelion at 68 kilometers per second, the world could only wait and wonder. Long before 3I/Atlas plunged behind the solar disk, it offered unmistakable signs that it was no ordinary visitor. In late August and September, NASA deployed the Swift Observatory, utilizing its high-sensitivity ultraviolet instruments to observe the object. Swift detected profound, invisible glow, the signature hydroxyl radicals, molecular fragments left behind when intense solar radiation tears water molecules apart. At nearly 3 times the distance between Earth and the Sun, 3I/Atlas was venting water at a rate of 40 kilograms every second. To appreciate the scale, this is comparable to a high-pressure fire hose operating at maximum capacity in a deep freeze. Standard astrophysical models suggest water ice should not sublimate this aggressively so far from the Sun, indicating that 3I/Atlas was violently shedding volatile, icy grains into its expanding coma.
While ground-based astronomers were temporarily blinded during October 2025, humanity's deep space Sentinel fleet remained active. Positioned throughout the solar system, 3 critical spacecraft, Stereo A, SOHO, and the newly launched GOES 19 satellite, held a clear view. Using specialized coronagraphs to create artificial solar eclipses, researchers tracked the visitor's run toward the sun. The resulting data revealed a stunning physical transformation. Typically, a comet's brightness increases as its distance to the sun decreases, scaling to a power of R-3.8. However, as 3I/Atlas crossed the threshold of 2 astronomical units, this curve turned nearly vertical, spiking to an unprecedented R-7.5. The object was shedding mass at an accelerating rate that challenged conventional models of primordial solar system comets, transforming into a brilliant beacon visible even to dedicated amateur astronomers back on Earth. The sudden surge in brightness was accompanied by a dramatic change in appearance. For months, observers recorded a dark red hue, highly characteristic of dusty, organic-rich surfaces like the interstellar object Oumuamua. Then, it transitioned to green before revealing a distinct blue signature to the space observatories. This blue color represents the specific spectral signature of carbon monoxide and amide radical emissions. It suggests that the intense thermal energy of our sun was actively stripping away the object's ancient, protective outer mantle. As this dark, dusty red crust disintegrated. It exposed highly volatile ices buried deep within the interior. What observers were witnessing was the unveiling of the object's true core, a highly active, gas-driven engine that had remained frozen in the deep freeze of interstellar space for millions, perhaps billions, of years.
Just prior to its solar encounter, 3I/Atlas made a remarkably close transit past Mars, passing within 28 million kilometers of the planet. This cosmic alignment allowed a fleet of active Martian explorers to conduct valuable science. NASA's Mars Reconnaissance Orbiter targeted its powerful high-resolution imaging science experiment camera toward the visitor. Because this instrument can resolve features as small as a coffee table from orbit, scientists hope to identify a clear image of the interstellar nucleus. However, a temporary government shutdown delayed the processing of these images, fueling speculative theories online about an extraterrestrial discovery. When the images were finally published 6 weeks later, they revealed a highly diffuse, unresolved structure. The solid nucleus remained completely concealed within a massive, 1,500-kilometer wide shroud of dust and gas, leaving its precise dimensions a mystery. Despite the lack of a sharp surface image, the Martian campaign yielded historic scientific data. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter successfully monitored the object's trajectory, while NASA's MAVEN spacecraft mapped a vast, invisible hydrogen envelope wrapping far beyond the visible coma. On the dusty surface of Jezero crater, the Perseverance rover angled its mass Z toward the night sky. In the resulting long exposure frames, 3I/Atlas appeared as a delicate, ghostly smudge drifting against a backdrop of distant stars. Though visually subtle, this observation represented a profound milestone in space exploration. The first time humanity has ever imaged an interstellar traveler from the surface of another world, proving that our robotic outpost can collaborate to study the cosmos from multiple planetary platforms.
As 3I/Atlas emerged from its perihelion passage, rumors of its demise began to circulate. Some researchers suggested that the object had succumbed to the sun's immense tidal and thermal forces, fragmenting into 16 distinct pieces. This hypothesis was supported by calculations indicating that such a rapid loss of mass was fundamentally unsustainable for a typical, loosely bound comet. However, subsequent observations from the Lowell Observatory and the Virtual Telescope project quickly clarified the situation. The interstellar visitor had survived its fiery transit intact. There was no chaotic debris cloud or trailing train of fragments. The apparent explosion was actually a brief, highly energetic outgassing event, a dramatic release of pent-up volatile gases that temporarily mimics a fragmentation event, showcasing the remarkable structural resilience of this ancient deep space traveler. The survival of 3I/Atlas did little to quiet the ongoing debate regarding its origins. Proponents of alternative hypotheses pointed to two anomalous features: an unusual sunward jet and a subtle, non-gravitational acceleration along its trajectory. It was argued that the immense outgassing required to produce this thrust would have obliterated a natural comet, suggesting instead the possibility of artificial propulsion. However, established planetary science provides highly robust, natural explanations for both phenomena. Sunward jets, while counterintuitive, are well documented in active comets. As the sunward face of the object experiences intense heating, volatile pockets rupture, venting gas directly toward the light source. The solar wind then bends this material backward, creating a forward-pointing fan of dust that, from our terrestrial perspective, resembles a powerful forward thruster, similar to features observed on comets Halley and Neowise.
The physical nature of this trajectory was further clarified by dynamic modeling of the object's flight path over the last century. Researchers demonstrated that its non-gravitational acceleration is entirely consistent with the rocket-like force of vending water and carbon dioxide. To resolve the debate, the MeerKAT radio telescope array in South Africa targeted the object, detecting distinct absorption lines at 1665 and 1667 megahertz. This signal corresponds precisely to the hydroxyl radical, providing a direct measurement of water density deep within the coma. This represents the first time radio emissions have been captured from an interstellar object, confirming that 3I/Atlas is a natural, ice-rich body rather than an artificial structure. If this were a metallic, dry spacecraft, this specific water-based signal would be entirely absent, solidifying its identity as a volatile-rich interstellar comet. While 3I/Atlas is undoubtedly a natural comet, it is far from pristine. Data from the James Webb Space Telescope and the SphereX mission revealed a carbon dioxide to water ratio of 7.6. In typical solar system comets, this ratio is a mere 0.12. This means 3I/Atlas contains nearly 60 times more carbon dioxide than expected, resembling a highly unstable dry ice deposit. Scientists propose that this chemical anomaly is the result of deep space weathering. During its long journey through the interstellar void, the object was bombarded by high-energy galactic cosmic rays for billions of years. This radiation broke chemical bonds within the outer 20 meters of ice, transforming simple carbon monoxide and water into a thick, heavily processed crust of carbon dioxide and organic solids. We are not observing a pristine interior, but rather a space-baked crust peeling away.
This baked crust is not the only surprise hidden within 3I/Atlas. Spectroscopic analysis from the Very Large Telescope in Chile identified trace amounts of nickel and iron gas within the coma, matching the signature of rare carbonaceous chondrite meteorites found on Earth. This metallic presence suggests a fascinating subterranean mechanism. When subterranean ice melts, it comes into contact with these metallic grains, initiating exothermic Fischer-Tropsch catalytic reactions. This process generates heat, which melts adjacent ice, creating an active feedback loop. The resulting buildup of gas pressure beneath the process crust eventually ruptures the surface, triggering powerful cryovolcanic eruptions. This catalytic process explains the sudden, dramatic surges in brightness, the unexpected forward-facing jets, and the high concentrations of vaporized metals detected in its coma, painting a picture of a remarkably complex chemical engine traveling between the stars.
Having survived its solar encounter, 3I/Atlas is now outbound, retreating back toward the interstellar darkness. On March 16, 2026, the object will perform a remarkably close pass of Jupiter, traveling deep inside the giant planet's hill sphere. While it moves too fast to be captured, Jupiter's massive gravitational field will permanently alter its trajectory, providing a final observation window for NASA's orbiting Juno spacecraft. This visitor has taught us that the vast expanses between stars are not empty, but are active environments that physically shape the objects traversing them. 3I/Atlas may not be an alien vessel, but an ancient messenger carrying the chemical signatures of a distant, unknown stellar system. Its journey reminds us that even a simple, frozen rock can serve as a profound testament to the shared chemical laws that govern our universe. As 3I/Atlas slingshots past Jupiter and vanishes into the dark abyss forever, it leaves behind a chilling reality. Our universe is far more alive, volatile, and complex than we ever imagined. But this isn't the end of the story. Is space hiding more of these active interstellar travelers heading straight for us? Click the video on your screen right now to uncover the terrifying secrets hidden at the edge of our solar system. And don't forget to subscribe, because the universe isn't waiting for anyone.